This comet's really cool because it does have that tail from the sun's radiation blasting it, but it also has a forward-facing tail.
If the sun is here and the comet is here, the sun sends the solar wind to the comet, the tail goes behind the comet. Guess what? This comet is at the reverse side.
But is it nature or something else? We're gonna find out soon.
Imagine a comet with a tail pointing the wrong way, not away from the sun, like every comet you've ever seen, but straight toward it. Sounds impossible, right? Well, astronomers have been watching exactly that happen with an interstellar visitor called 3I Atlas, and the physics behind it is absolutely mind-blowing. Stick around because this cosmic mystery just got even stranger. As of November 15th, 2025, scientists are still observing something extraordinary. An interstellar object displaying both a normal tail and an anti-tail. A tail pointing toward the sun instead of away from it. This isn't your typical comet behavior, and astronomers around the world have been scrambling to figure out what's going on. The latest image comes from Thailand, captured by Tirasak Thalong using a telescope, and it shows this bizarre feature is still going strong. So what's causing this backward tail? Is it natural physics, or could it be something more unusual? Let's break down the science. When the Hubble Space Telescope imaged it back in July 2025 at about 4 astronomical units from the sun, that's 4 times the Earth-Sun distance, scientists noticed something weird. It had a prominent tail pointing toward the sun, not away from it, like normal comets. And here's the kicker. This anti-tail wasn't just a trick of perspective. Usually, when you see what looks like a sunward tail, it's actually old dust from previous orbits that just happens to line up with our viewing angle. But 3I Atlas is on its first pass through our solar system, and the tail is genuinely pointing the wrong way. So what could cause this? Scientists have proposed several explanations, and they're all fascinating. Theory 1, giant dust particles. The first idea involves unusually large dust particles, about 100 micrometers across. That's roughly the width of a human hair. These particles are 1,000,000 times more massive than typical comet dust. Because they're so heavy, the sun's radiation pressure can't push them away as effectively. So instead of forming a tail away from the sun, they hang around closer to the comet, creating this anti-tail effect. The catch? You'd need 100 times more mass loss to produce the same brightness, which seems like a lot. Theory 2. Ice fragments. Here's where it gets really interesting. Another possibility is that what we're seeing is actually fragments of ice, not dust. Here's how it works. The comet has a mixture of materials, about 80% water ice and 20% carbon dioxide ice. When the carbon dioxide sublimes, that's when it goes directly from solid to gas, it's so cold that it keeps the water ice from melting right away. This carbon dioxide gas acts like a jet, launching water ice particles off the surface. These ice particles travel toward the sun, scattering sunlight, and creating the bright anti-tail we see. But here's the thing. They're on borrowed time. As they travel, they heat up and eventually evaporate before they can turn around and form a normal tail. It's like they're in a race against their own destruction. The anti-tail is longest in the sunward direction because that's where the comet's surface gets the most heat, producing the strongest outflow and the largest ice particles. These larger particles last longer before evaporating, creating that extended sunward feature. Theory 3, the speculative one. And then there's the more, let's say, unconventional idea. Some have suggested that this could be evidence of technological thrusters, essentially artificial jets that would create tightly focused streams of material. These would need to move at several kilometers per second, much faster than natural outgassing, which typically moves at a few hundred meters per second. Future spectroscopic observations could actually test this by measuring the outflow speed. But wait, the story gets even more interesting. The anti-tail isn't static. It's been changing over time. When Hubble imaged 3I Atlas back in July 2025, the anti-tail was prominent and dramatic. But by late August, when the Keck and Gemini South observatories looked at it, something had changed. The anti-tail was fading, and a conventional tail away from the sun was starting to appear. The physics explains why. As 3I Atlas got closer to the sun, moving from about 4 AU to about 3 AU, the temperature increased dramatically. Remember those ice particles we talked about? At closer distances, they heat up faster and evaporate more quickly. There's actually a sweet spot around 3.5 astronomical units where the ice coma, that's the cloud of ice particles, reaches peak brightness. Closer than that, and the ice particles don't survive long enough to create that bright antitail. They evaporate too quickly. Instead, the scattering shifts to longer-lived dust particles and larger ice chunks that can survive to form a traditional tail. It's like watching the comet switch personalities as it approaches the sun. The researchers found that the lifetime of water ice grains drops exponentially with temperature, while the carbon dioxide sublimation rate increases. These competing effects create the very narrow window where we can see the dramatic antitail phenomenon. So what can we expect as 3I Atlas continues its journey? The comet is heading toward its closest approach to Earth on December 25th, 2025. That's just about a month away as of this recording. As it gets closer, we should see more of that conventional dust tail and less of the antitail, or the antitail may disappear entirely. The increasing sunlight will cause more carbon dioxide to sublime, launching more material off the surface, but the ice particles won't last long enough to create the sunward feature. Astronomers are planning extensive observations during this close approach. They'll use spectroscopy to measure the exact speeds of the outflowing material, which will help definitively distinguish between natural outgassing and other possibilities. They'll also track the chemical composition and see how the comet's activity changes with distance. This flood of data over the coming weeks will be crucial. It's detective work on a cosmic scale, gathering evidence, testing theories, and piecing together what's really happening with this mysterious visitor from beyond our solar system. The antitail of 3I Atlas reminds us that the universe still has plenty of surprises in store. Whether it's giant dust particles, sublimating ice fragments, or something we haven't even thought of yet, this interstellar visitor is teaching us new things about comet physics and the diversity of objects traveling through our cosmic neighborhood. And here's what I love about this story. Scientists are showing us the process in real time. They're not claiming to have all the answers. They're collecting data, proposing hypotheses, and being willing to say, we don't know yet. That's real science in action. What do you think is causing the antitail? Ice particles? Dust? Something more exotic? Let me know in the comments below. And if you want to stay updated as we approach that December close encounter, make sure to hit that subscribe button and ring the bell for notifications. Thanks for watching, and I'll see you in the next video. Keep looking up.